This video demonstrates how to analyze the retail mart data. There are two sheets in this dataset. First is a training data, and this is the data we use to run the regression and find out the regression coefficients. And then there's a test data. The test data is what we use as a holdout sample. That is, we have a new group of customers and we're going to use the regression results to predict whether they are pregnant or not. So now, going back to the training data, first let's create a duplicate copy of this dataset. Right-click on training data, left-click on move a copy. Now check create a copy and click OK. Now we have a new sheet. Let's rename this training data with dummy. So by dummy, I mean we need to do the dummy coding on the categorical variable here, whether the address is home, apartment, or PO box. All the other variables are already in numerical terms, so we don't need to do anything about it, but we need to code this data. And to do this, we have 3 levels on this discrete data, so we only need 2 dummy variables to code them. Click on B and C columns, and then right-click, insert. So now we have 2 new columns. We're going to name column B home and column C apartment. And these are the 2 columns we use to generate the new variable. For home, we use equals if parenthesis, and if the cell next to it is equal to capital letter H, then it's 1, otherwise it's 0. And close the parenthesis, enter. So this variable will be 1 if it's a home, and 0 if it's not. And similarly, we're going to do it on apartment, equals if, parenthesis, if this is equal to, quote, capital letter A, then it's 1, otherwise it's 0. And then we're going to select these 2, hover your mouse on the lower right corner, and a double click. So now we have the dummy variables created using 2 dummy variables to represent a categorical variable of 3 different levels. And now we can use this data after coding to run a regression. So go to Data, Data Analysis, and on this menu, select the regression and click OK. Now we have the interface to run regression in Excel. We're going to specify the y variable and x variables. So for the y variable, we're going to select the whole column of pregnant, so column S. So select the first cell and hold down Control and Shift key and the down arrow together. So all 3 together. And now we have selected from S1 to S1001. We have 1,000 data points. And the first row is the variable name. Now we're going to select X. Go up. And the X would be from column B to column Q. Note that we're not selecting the whole column. We're only selecting part of the column that includes all the variables. So I have just selected the first row. Now use your keyboards to hold down Control and Shift and then down arrow. You can use a mouse to select this area as well. So in this case, now we have the X range being from B1 to Q1001, basically the whole region with all the X variables. Now check labels, because the first row includes the variable names. Here it's going to create a new sheet for the regression results. So let's call the new sheet results and then click OK. It's instant. Now Excel has done the regression, and let me change the layout a little bit, making it easier to read, and reduce the decimal points. All right, so now we have the regression results. Again, we usually take a look at some of the most important metrics. R-square is 0.45. This is actually a pretty good R-square. And significance level for f-stat is 1.39 times 10 to the power of minus 115. And this is actually a puny number. This represents 0.00000. There are 114 zeros, and then 13947. So this is a tiny p-value, which means the combination of these variables we put in has a very strong statistical association with the dependent variable, that is the y, pregnant. Now, next we look at the coefficients. We can conditional format this so that we can see the positive and negative numbers more easily. And then we take a look at the p-value for these coefficients. And we are going to highlight the cells that are significant, 0.0, 0.5. I'm going to use green since significance is good. And what you see here is that two of the estimated variables are not statistically significant, which basically means we didn't find association between the type of residency versus pregnant. So these two variables are not predictive of pregnancy. But all the other variables we have included are significant. If you take a look at these variables, the sign of these coefficients, they all make sense. If they, for example, if they purchased pregnancy test, then it's actually a positive indicator of pregnancy. And buying birth control is negatively associated with pregnancy, no surprise there. If you look through all these variables, they're actually all interpretable in terms of the signs. So usually when you run a regression, you kind of stop here because your focus may just be how the coefficients look like, the signs and the magnitudes of these regression coefficients. Let me put down the equation here just so that we're on the same page in terms of having the regression results. So what this regression result shows is that pregnant is equal to 0.438, that's the intercept, and minus 0.0 times home. Note that home is a dummy variable here, 0, 1, and minus 0.013 times apartment, and then plus 0.224 times pregnancy test, and etc. So basically all these coefficients will be multiplied into the variables we have. That gives us the equation to predict pregnant. Now we're going to use these estimated coefficients to produce a prediction based on this new set. Let's say we have a new set of customers and we want to use this model to predict whether they are pregnant or not. And to make use of these coefficients, the most convenient way is to copy and paste them into the test set. We're going to paste the transpose because we want the coefficients to be in a row, then it will be easier to use when we multiply them into these variables. So if you right-click on the cell, the fourth choice here with two arrows, this will transpose what you have copied. Now we have these coefficients. We're going to multiply these coefficients into the variable values to predict the pregnancy. So we are going to produce predicted pregnancy here. So to produce the predicted pregnancy, we'll simply use all the coefficients and multiply them into the variables. So the coefficients are here. We're going to start with the intercepts, V2, and use F4 here. You need to lock it up. And because we want to copy this formula down, we don't want the reference to the intercept to move around. And then plus all the coefficients on the right, multiplied into the variable for each customer on the left. So here, there's a formula to do this quickly. It's called sum product. And what sum product does is it's going to multiply this row of coefficients. And we want to lock this F4, comma, into the variables of each customer and then sum it up. So it's element by element multiplication and then sum up all the multiplication results and then enter. So once we've done that, we can just copy this formula down. In order to see the magnitude of this, you can run a conditional format on this so that you can see some values bigger, some are smaller, and the higher these values are, the more likely we are predicting this customer is pregnant. And let's check, looks right. So what we have is the coefficients are staying in the same place, but this prediction moves with the customers. All right, next we want to find a cutoff for the pregnancy prediction, because these predicted pregnancy, they are continuous variables. But at the end of the day, we are predicting a binary event, whether pregnant or not. So we want to find a cutoff value. To do that, we need to take a look at what kind of cutoff value gives us the best performance. And we're going to rely on a chart to inform us how to do this. And the chart is called Receiver Operating Characteristic, or ROC. And to produce that ROC, let's take a look at the performance. I'm going to create a new sheet called performance. And in performance, first I'll take a look at the prediction range, the minimum prediction and the maximum prediction. So the minimum prediction is equal to mean of the predicted value of the pregnancy from 1001 to 2. So, and enter. And then the maximum prediction is to the maximum in this range. Enter. So now we know that the range of these values are between minus 0.32 to positive 1.26. And we want to find a cutoff value for probability of pregnancy. So say probability cutoff for pregnancy classification. And let me make the text wrap around, easier to read. Wrap text. Okay. All right, so given the range of these mean and the maximum prediction, we are going to start from minus 0.35 and minus 0.3. So we want the cutoff. So we want to decide the cutoff based on between the minimum and the maximum. So I'm going to select these two, hold on the lower right corner, and Excel is going to allow me to create automatic incremental values. So I'm going to drag this all the way until 1.25. What I want to calculate is at these different cutoff values, what is the precision of my prediction? What is the false positive rate of my prediction? And what is the true positive rate of my prediction? So these are the three things I'm going to calculate. And the definition of these three measurement metrics are included in the slides. So I'm going to start with precision. Precision is the ratio between true positives and the total predicted positives. So we're going to do this using COUNT-IFs. Basically, true positives means predicting to be pregnant and is actually pregnant. So the conditions are, when you go to test set, is the prediction. If we predict these to be pregnant, use F4 to lock this. And predicting pregnant means this value is larger than or equal to, put the and sign there. This is on top of the number key 7. Larger than or equal to our cutoff value in cell B2 on the left here. And so second condition is that actually they are pregnant as well. Not only do we predict them pregnant, they're also actually pregnant, which means on this column, and F4 to lock this, comma, and they are actually pregnant means quote equals 1. So these values are equal to 1. So this gives us the numerator for precision, that is the true positive, and in the denominator, in this case, is the total predicted positives. So we're going to be dividing this by COUNT-IF, parenthesis, and we are counting the predicted positives would be basically in the predict pregnancy column. And the predicted positives would be, let's say, F4 and comma, and they are predicted to be positive, which means larger than or equal to, and this cutoff value. And then close the parenthesis and enter. So this is basically the precision that that we have, and we can easily copy this down to all the different numbers. So what this represents is at these different pregnancy cutoff values that our precisions actually increase when we have a higher cutoff value. But you're going to see that it comes at a cost because you are giving up predicting a lot of pregnancies when you leave a lot of money on the table that you're not predicting some highly likely pregnancy cases if you are pursuing a perfect precision. So next I'm going to calculate the false positive rate and the true positive rate. So for the false positive rate, the numerator is basically the count of false positives. So we're going to use again COUNT-IFs. So for false positive, it means we predict them to be positive, but they are actually not. Which means in the test set of these pregnancy cases, F4, comma, we predict them to be pregnant, so larger than or equal to this cutoff value. But they are actually not, means the actual pregnancy column from R2 to R1001, F4, and then this, they are not pregnant, so they are equal to 0. That's the numerator. The denominator is the total count of not being pregnant, so use COUNT-IF, the actual pregnancy here, R2 to R1001, F4, they are actually not pregnant, so equals 0. and enter. So we can copy this down, reduce the decimal points. Okay, so that's the false positive rate. Then we calculate the true positive rate. True positive means predict them to be pregnant. They are actually pregnant. So the numerator is count ifs, predict them to be pregnant. So this predicted pregnancy column. And F4 to lock it. We predict them to be pregnant, so larger than or equal to, and the cutoff value. And they are actually pregnant. So the actual pregnant cases are 2 to R1001, use F4 to lock this, comma, they are actually pregnant means quote equals 1, they are actually equal to 1, and divided by the total count of pregnancy. So count if, and again this column of R2 to R1001, and comma, they are actually pregnant, and enter. So now I have true positive rate. Reduce the number of decimal points. As you can see that false positive rate and true positive rate, they are opposite concepts, because we want the true positive rate to be high and the false positive rate to be low. But then let's draw this. We're going to create an ROC, receiver operating characteristics, that tells the relationship between false positive rate and true positive rate. So select these two columns, insert a scatter chart, and we're going to do a line only chart here. Click on this. And what this chart shows is that, let me put on the labels, the axis labels. The x-axis is false positive rate. The y-axis is the true positive rate. And this chart is an ROC. So what this shows is that when the false positive rate increases, the true positive rate increases as well. So the bad thing increase, the good thing also increase. The bad thing decrease, the good thing also decrease, which means you cannot have the best of both worlds. You have to make a compromise. So the thing to notice is that when you look at the beginning of the curve, here the true positive rate is increasing very fast. The vertically it's increasing very fast. And the false positive rate horizontal side is actually not increasing that much along the line. But towards the end, what happens is that when you have a high cutoff value towards the end, the true positive rate actually does not increase a lot. It's fairly flat. But the false positive rate increases very fast. So at the end of the day, you want to strike a sweet spot where the line started to turn. So somewhere around here where you have a high true positive rate, but the false positive rate has not picked up yet. So that region is represented roughly here. So where you have a relatively high true positive rate, about 75%, and the false positive rate is only about 10%. And the cutoff is somewhere between 45 and the cutoff is somewhere between 0.45 and 0.55. So at the end of the day, when you are running a business, you may not choose this turning point. For example, if you are more conservative, you really don't want false positive, then you might choose a higher cutoff value. For example, here, when you choose 0.65 as the cutoff, then what happens is you have fewer false positives, so you predict less wrong pregnancy. So there are no angry parents. But in the meantime, when you choose to be more risk averse, you are also giving up potential customers that are pregnant, and you could predict correctly because you are giving up on true positive rate. So if you are conservative, you may go this direction. If you are more aggressive in your predictions, then you may head this direction. Here you can have a 95% true positive rate. In the meantime, your false positive rate will be pretty high as well, almost 50%. So depending on your risk preference and what you want to achieve, you can choose different cutoff points. And in this case, generally speaking, to strike a balance, the cutoff should be somewhere in this range. That finishes this video.